In this first video, we're going to go over some fairly basic stuff. Or, well, maybe not that basic, but it's stuff that the textbook makes use of that they don't actually explain first, which is a little bit annoying given that this is, meant to be an introductory logic class, and you can't assume that people actually know things like what a recursive definition is. Um, so we'll talk about that in this video. Okay, so we will start with the notion of a set. So a set is pretty much any group of objects. The pretty much will come back to later on, I think. We'll talk about after we go through a few other things about paradoxes and things like that. We can actually talk a little bit about what kinds of things are sets and aren't. But for now, what you can just think of is that a set is any group of objects, right? Any of them count as a set. Um, to write a set, what you do is you take the objects that it contains and you enclose them in curly brackets. So this is the Beatles here, right? You can write the Beatles as the set John, Paul, George, and Ringo. Um, if you want to say that an object is in a set, then you use this symbol here. This is a variant form of the Greek letter epsilon, and it means what it indicates set membership, right? You can read it as is in the set. So this means object X is in the set S. So Ringo is in the set the Beatles, right? Two is in the positive integers. Um, Now, set is defined by its members, right? And not by how the members are described, which is a property that's called extensionality, right? What defines a set is its extension, right? Its membership or the objects that it contains. So, for example, John, Paul, George, Ringo, right? Paul, George, Ringo, John. These are both the same set, right? Changing the order in which you state the members doesn't change the set, which is just kind of the obvious point that if you take the objects that are in a group and then you rearrange them, it's still the same group of objects. Um, and then likewise, if you've got John, Ringo, Paul, Ringo, George, George, Ringo, 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 this is still the same set, right? Repeating the names of members of the set doesn't actually change it, right? Um, okay. If you're thinking of a set as a group of objects, this is going to be misleading in one way, which is that there are certain things that are sets that you probably wouldn't think of as being groups of objects. Um, Okay, first thing is, so you have infinite sets, right? So the positive integers are a set, right? These are the numbers 1, 2, 3, and so on and so forth, right? Those whole numbers are an infinitely large set. Um, Another one is you can have unit sets, right? This is a set that contains only one member. Although it's a little weird to say that, something is a group that only has one member in it, you can actually have a set that only has one member. So, for example, right, that is the unit set containing only Ringo Starr, right, and nothing else. That's the unit set containing two. A unit set and the object that it contains are not the same thing, right? Because Ringo Starr is a drummer from England, and the set containing only Ringo Starr is a set, and sets and drummers are not the same thing, so those are not actually identical objects. Now, the last one is the empty set, and this is the set that contains no members. You could write this as just like a pair of curly brackets with nothing inside, but the convention is that you use a sort of stylized zero symbol to indicate the empty set. In fact, actually, given the way that the numbers are defined, typically zero is actually just defined as the empty set. So the symbol makes sense, right? Because zero and the empty set turn out to be, on most accounts, the same thing. Okay, so that's a basic rundown of sets. And sets, I mean, the notion of a set is just something that the book makes use of constantly, right? I think it starts on page 4 when they start talking about sets.